Alright class, welcome to chapter 13, part 2 video lecture. And in part 2, we're going to go ahead and cover the first 3 steps of hypothesis testing. Step 1, stating our null hypothesis and equation. Step 2, stating our alternative hypothesis and equation. And then step 3, calculating the F-test statistic. And so in this video, we're just going to cover how to do the hand calculations for the F-test. In the following rest of the videos, we're going to see how we look at SPSS output and finish up steps 4 and steps 5. Okay, so here is our scenario. So this is a real case report that was published in 2007 in the Archives of Disease in Childhood. And the article was called Superhero-Related Injuries in Pediatrics, a Case Series. So here's some background. Children wearing superhero costumes are more likely to harm themselves because of the unrealistic impression of invincibility that these costumes could create. For example, children have reported to hospitals with severe injuries because of trying, quote, to initiate flight without having planned for landing strategies, unquote. So imagine we had data about the severity of injuries on a scale from 0 to 100, where 0 means no injury and 100 means death. Imagine we had this data for children reporting to emergency rooms and information on which superhero costume they were wearing. Were they wearing a Spider-Man costume, Superman, the Hulk, or Teenage Mutant Ninja Turtle? So here's our research question. Do different superhero costumes result in more severe injuries? So step 1, there are no differences between superhero costumes on severity of injuries. We're simply stating there's no differences between our IV on our DV. And so our null equation, the mu of Spider-Man equals mu of Superman equals the mu of Hulk equals the mu of Ninja Turtles. And of course, you want to then specify, if you were going to use this type of notation, what SPD meant, what SUP meant, what HLK meant, and what TUR meant. And again, the mu's all represent the population means. Step 2, at least one superhero costume is different from at least one other superhero costume on severity of injuries. So recall when I introduced SPSS inferential statistics and we covered the zombie dataset, that I talked about how when we have multiple groups, the minimum criterion for us to reject the null and accept the alternative is that at least 2 groups are different from each other. At least one group is different from at least one other group. Doesn't mean that all the groups need to be significantly different from each other. It just means that at least one group is at least one different from at least one other group. Hence, the verbiage for step 2 for ANOVA. And so when we state our equation for alternative hypotheses, we're simply stating that the sample mean for Spider-Man does not equal the sample mean for Superman, does not equal the sample mean of Hulk, does not equal the sample mean of Ninja Turtles. And I just used different notation here in terms of M, which means the sample mean. You can simply use X bar to replace M. I just wanted to show you that we can report this differently because the last week already we saw that when in our conclusions we're reporting the means and standard deviations for 2 groups, so we can simply do the same thing whenever we're reporting our equations. So here's our data. We have our 4 groups, Spider-Man, Superman, Hulk, and Ninja Turtles. And we have 8 children that wore each of these costumes. So each row is going to be an individual for each of those costumes. So if we have 4 groups and 8 rows, we have a total of how many people in our sample? 32. And again, looking at this data, this is the severity of injuries, where 0 means no injury and 100 means death. So step 3, calculating our f-test. So here is the equation, where f is equal to the mean sum of squares between groups over the mean sum of squares within groups. And again, we see that ms to the left stands for mean sum of squares, and b is simply between groups, and w is simply within groups. So let's break down what mean sum of squares between groups is. This is simply SSB over DFB, where SSB is the sum of squares between groups over the degrees of freedom between groups. And we see that the sum of squares between groups is going to be given to you. So I will always give you this number. But your degrees of freedoms between groups, that's something you have to calculate. So here's a formula for degrees of freedom between groups. K minus 1, where K is the number of groups. So to summarize the numerator, mean sum of squares between groups is equal to the sum of squares between groups over the number of groups minus 1. And so the denominator for our f-test is a mean sum of squares within groups. And what this calculation is the sum of squares within groups, which is also given to you, over the degrees of freedom within groups. And that calculation is your sample size minus the number of groups that you have. So we have both of our degrees of freedom. Thanks, Bobby the Bear. So to wrap up our full f-test formula, f is equal to mean sum of squares between groups over mean sum of squares within groups, which that is equal to the sum of squares between groups over the number of groups minus 1, all of that over sum of squares within groups over the total sample size minus the number of groups. And notice that whenever we report our F statistic, we always include immediately after F what our degrees of freedom between groups is and the degrees of freedom within groups is, separated by comma, both enclosed within parentheses. So let's work through a calculation. So here is our data. This is what's given to you. You will also be given your sum of squares between groups and your sum of squares within groups, as we can see here. Sum of squares between groups is 6,075.34, and sum of squares within groups is 4641.13. What you need to calculate are your degrees of freedom between groups, degrees of freedom within groups, and your actual f-test. So go ahead, pause the video, and try to work through calculating your f statistic given the formula we just covered and the data given here. Once you've worked that through, go ahead and unpause the video and see if you get the right answer. Alright, so let's see how you did. So our degrees of freedom between, the formula is k minus 1, where k is equal to the number of groups. So how many groups do we have in our entire sample? We have 4 groups. We have Spider-Man, Superman, Hulk, and Teenage Mutant Ninja Turtles. So degrees of freedom between groups is equal to 4 minus 1, which is equal to 3. Now let's work through degrees of freedom within groups. Well, what's the formula for degrees of freedom within groups? Total sample size minus the total number of groups. So if you recall, I mentioned that each row is an individual within each group. And since we have 8 rows and 4 groups, we have a total of 32 individuals. So plugging and chugging into our degrees of freedom within groups formula, 32 minus 4 is equal to 28. So now that we've calculated our degrees of freedom between groups, and our degrees of freedom within groups, we can then plug and chug all that information along with what's been given to you, your sum of squares between and within groups, into your overall F-test. So we plug and chug, and we get this. All of that is then equal to 12.218. So notice that when we state our final answer, we're stating F, degrees of freedom between, minus degrees of freedom within, is equal to our F statistic.
All right, now that we know how to hand calculate our F-tests, let's go ahead and go to part 3, video lecture for chapter 13, to look at how we make our decision, as well as how we get our output through SPSS, and how we make our decision that way as well.